Hello friends, today we are going to see class 10th science second chapter acids, bases and salts, so let's start. Acids. Introduction. An acid is any hydrogen containing substance that is capable of donating a proton or hydrogen ion to another substance. Arrhenius definition. Any substance that, when dissolved in water, increases the concentration of hydronium ion H3O+, is called as acid. Sulfuric acid can donate 2 protons or hydrogen ions in an aqueous solution. Thus acids are proton donors or electron acceptors. Ben Mills. Example, H2SO4, HCl, CH3COOH. Properties of acids. They taste sour. The word acid comes from the Latin acer, which means sour. Acids can change litmus from blue to red. Aqueous solutions of acids can conduct electric current. Acids react with bases to form salts and water. Acids can release H upon reaction with an active metal such as zinc, aluminum etc. Classification of acids. Strong acid. They break down completely to give off many H+ ions in their aqueous state. Weak acids. They partially breaks down, gives less number of H+ in their aqueous solutions. Some common acids. Strong acids. The formula: sulfuric acid, H2SO4, hydrochloric acid, HCl, hydrobromic acid, HBr, hydroiodic acid, Hi, nitric acid, HNO3, perchloric acid, HClO4. Some weak acids are: weak acid. The formula: acetic acid, vinegar, carbonic acid, CH3COOH, H2CO3. Uses of acids. Acids have numerous uses, some of which include HCl in stomach, H2SO4 in car batteries as drying agent, HNO3 in manufacturing of fertilizer, ethanoic acid in food industry, fatty acids in soap making, ascorbic acid in medicine. Bases. Bases produce O ions in aqueous solutions. Bases are proton acceptors. Bases are electron pair donors. Least restrictive of acid-base definitions. Examples of bases: NO, MgO2, CaO2. Properties of bases. Bases taste bitter. Bases are slippery or soapy to touch. Bases can turn acidified red litmus to blue. Their aqueous solutions conduct electric current. Bases react with acids to form salts and water. Classification of bases. Strong bases. A strong base is a basic chemical compound that can release hydroyl ions in maximum amount. Common examples of strong bases include hydroxides of alkali metals and alkaline earth metals like NO and CaO2. Strong bases. Formulae: potassium hydroxide, Co. Barium hydroxide, BaO2. Cesium hydroxide, CSOH. Sodium hydroxide, No. Strontium hydroxide, CnO2. Calcium hydroxide, CaO. Lithium hydroxide, Li. Rubidium hydroxide, Rbo. Weak bases. A weak base is a basic chemical compound that can release hydroyl ions in less amount. Common example of weak base is NH4OH. Strong bases. Formulae: ammonia, NH3, methylamine, CH3NH2, pyridine, C5H5N, ammonium hydroxide, NH4OH. Preparation of bases. There are various methods for the preparation of bases. Reaction of oxygen with metals to form metal oxide. Many metals react with oxygen gas to form the metal oxide. For example, calcium reacts in the following manner: 2 Cas plus O2 grams 2 cows. Thermal decomposition of carbonates. Metal carbonates such as calcium carbonate break down when heated strongly. This is called thermal decomposition. Here are the equations for the thermal decomposition of calcium carbonate. CaCO, right pointing arrow Ca plus CO. By double decomposition reaction. A chemical reaction between two compounds in which parts of each are interchanged to form two new compounds. AB plus CD equals AD plus CB. By dissolving basic oxides in water. The oxides of feebly acidic cations react exothermically with water producing the hydroxide. Ca plus HO less than to CaO2. Uses of bases. Greater than sodium hydroxide caustic soda is used in the manufacture of soap. It is used in petroleum refining, in making medicines, paper, pulp, etc. It is used in making rayon. Greater than calcium hydroxide is also known as slaked lime. It is used to neutralize acid in water supplies in the manufacture of bleaching powder, as a dressing material for acid burns, as an antidote for food poisoning, in the preparation of fungicides and in the mixture of whitewash. It is mixed with sand and water to make mortar, which is used in the construction of buildings. It is also used by farmers on the fields to neutralize the harmful effects of acid rain. Greater than ammonium hydroxide is used to remove ink spots from clothes and to remove grease from window panes. It is used in the cosmetic industry. Alkalis are used in alkaline batteries. Generally, potassium hydroxide is used in such batteries. Salts. When H plus ion of an acid is replaced by a metal ion, a salt is produced. Here sodium sulfate, Na, so is the salt formed. The chemical symbol for table salt is Nacl. Properties of salts. Most of the salts are crystalline solid. Salts may be transparent or opaque. Most of the salts are soluble in water. Solution of salts conducts electricity. Salts conduct electricity in their molten state also. The salt may be salty, sour, sweet and bitter. Neutral salts are odorless. Salts can be colorless or off-colored. Classification of salts. There are different kinds of salts. These include 1. Normal salt. The hydrogen ions of the acid are completely replaced by metallic ions. Examples are Nacl, CuSO4, KNO3, and CaCO3. Normal salts are electrically neutral. 2. Acid salt. The salt still has hydrogen atoms from an acid which can further be replaced by metallic ions. Examples include NaSO, NaCO, etc. 3. Basic salt. The salt contains hydroxides together with metallic ions and negative ions from an acid. Examples are basic zinc chloride, ZnOHCl, basic magnesium chloride etc. Uses of salts. No. 1. Salt. Ammonium chloride. Use. In torch batteries. 2. Ammonium nitrate. In fertilizer. 3. Calcium chloride. As drying agent. 4. Iron sulfate. In iron tablets. 5. Magnesium sulfate. In medicine. 6. Potassium nitrate. 7. Silver bromide. 8. Sodium chloride. 9. Sodium stearate. In gunpowder etc. In photography. Making No. In making soap. pH scale. The negative logarithm of the hydronium ion concentration of an aqueous solution, used to express acidity. pH is the measure of the acidity or basicity of a solution. The pH scale ranges from 1 to 14. 1 through 6 being acidic. 7 is considered neutral. 8 through 14 being basic. pH is a way to measure how acidic or basic a solution is. Low pH values equals acids. High pH values equals bases. pH measures the concentration of hydrogen ions equals H+.